All right, in this lesson, we're going to continue on with Standard 4. And what we're going to do is really just try to get you more comfortable uh, working on circles and on particular the unit circle in terms of being able to determine your location given certain information. So here's an exercise that's helpful for doing that. So it says, suppose that the terminal point determined by t is the point 3/5, 4/5 on the unit circle. Now, this number t here that we're talking about, you could think of that as the angle. But remember, on the unit circle, angle and arc length are the same thing, right? Because if s equals r theta, the arc length is equal to the radius times the angle. On the unit circle, we know that the number 1 belongs there, right? So it would be s equals 1 times theta. So arc length and angle are really the same thing. So what that means is instead of trying to draw t as an angle, it's okay for me just to think of it as an arc length, right? Now remember, we're always starting from the standard position, so this would be 0. So they're saying that the terminal point determined by t is 3/5, 4/5. That's the point on the unit circle where t ends. All right, so I'm going to pick a different color here. So let's just try to approximate about where 3/5 is, right? Here's what I would say is about half, and 3/5 is a little above half, so I'd put it right there. And let's follow it up, and that certainly looks like it's at a height of about 4/5, okay? So this is where the terminal point for t is, okay? And we know that that's the point 3/5, 4/5. So now they're going to ask me questions of variations on t, okay? So t starts from that standard position, goes up t, and there's my terminal point. So let's think about pi minus t. So where is pi minus t? Well, let's think of it like this. Pi is half of the circle, right? So that would take us all the way to here. Minus t would mean that I am going to then go the negative direction t, right? But I'm going to go in the negative direction the same exact distance that I went here, but I'm just going backwards. So I end up right here. So if this is where pi minus t is, okay, what is this point? Well, it certainly appears that their y values are the same, and their x values also look the same, but they're just opposites of one another. So what I can safely say here is that the terminal point for pi minus t would be negative 3/5, but then the same y value, positive 4/5. All right, we can do the same sort of thing for negative t, okay? So if this is positive t, to start here and go t in this direction, then negative t just means I'm going t in the clockwise direction, right? So that's where negative t takes me. And so, of course, there I can see that the x's are the same, but the y values are opposites. So this would be 3/5, negative 4/5. All right, and then C here, pi plus t. Okay, so I'm going to go pi, but I'm going to continue to go in the positive direction or the counterclockwise direction t. So then I'm going to go that same distance t, but this way from pi. And so that's pi plus t. And so that one, it looks like has the opposite x and the opposite of y of t. So I would say this is negative 3/5, negative 4/5. 2 pi plus t, well, 2 pi is once around the circle, so I go 2 pi, and then I go another t, and guess what? That lands me right back to the same place I started, 3/5, 4/5. All right, now I'm going to switch colors here for these last two. They're a little trickier. So let's think about what it means to go pi over 2 plus t. So going pi over 2 means I'm going to go up to here, and then I'm going to go t from there. So what I want is to go this same distance, but starting from the top of the circle. Okay, but I'm really trying to make this distance match this distance. So that puts me right about there to eyeball it. So there's pi over 2 plus t. So let's think about what that is. It certainly seems like the x's and the y's have switched and also maybe switched signs. Okay, and maybe what's most helpful is to look at this one here. Okay, when I go pi over 2 plus t, it certainly seems like now the x is negative 4/5, right? And the y is positive 3/5. Okay, so it seems like the x and y have kind of switched roles. And in fact, that's exactly what happens whenever you make pi over 2 or 3 pi over 2 your starting point and then go t from there, then whatever t was, you are switching the roles of x and y. So negative 4/5 for our x, positive 3/5 for our y. And pi over 2 minus t, so if I go pi over 2, go here, and then I'm going to subtract t. So I'm trying to go back that exact same distance t, pi over 2 minus t. So that one certainly seems like, again, x's and y's have switched, but in this case they're both positive, so it'd be 4/5, 3/5. All right, so kind of another different sort of exercise is this one. And this is one where I'd like you to really use your knowledge of the unit circle and see if you can figure out parts A through E before you take a look at the rest of this video. So really give this a good try yourself first. And again, what I'll leave you with here is remember that since it's the unit circle, arc length is the same as your angle. Okay, those two things are the exact same thing. So with that in mind, I want you to try parts A through E. All right, so coming back here, let's see what kind of progress we can make. All right, so arc length and angle are the same. The first question is, Todd has run 3.5 miles. What quadrant is he in? So first of all, we understand that 3.5 miles, that's an arc length, right? That's an S. But that also means that his theta is 3.5, right? Because we're on the unit circle and they're the same. So let's try to envision where this puts Todd at. Okay, so kind of my poor excuse for a circle here. It'll do. Okay, so where is 3.5 miles? One of the things you're going to find really helpful is whenever you're working with radians, which we really are here, right? Because theta is going to be in radians because this is all coming from the formula S equals R theta. Okay, so theta is always in radians there. So when you're thinking about 3.5 radians, be able to take some of the really special values on the unit circle and know their approximation. So pi over 2, which we know is up top, that's about 1.57, right? Pi, that's the one we should all know, 3.14. 3 pi over 2 is approximately 4.71, and then 2 pi is 6.28. So keep those approximations in mind, and if you do, then you realize, okay, I think I know where 3.5 miles is, right? That's got to be in quadrant 3, right? It's just past pi. So we can answer confidently here that it is quadrant 3. Now it says Lizzie has traveled 3.5 miles. Okay, how does her location on the unit circle compare to Todd's? Okay, so what did Todd do? Right, Todd ran 3.5 miles, and this is Todd's journey here, right? All the way to that dot. Okay, so what's Lizzie's journey then? If she's 2 pi minus 3.5, use a different color for Lizzie, that means she goes, you can think of it as 2 pi and then minus 3.5. So what we want is for Lizzie's path to be the same length. Well, I guess I should say it this way, that this green going backwards 3.5 should be the same length as Todd's red path, right? But going in the opposite direction. And so that puts her right about there. And so if we compare those two to each other, for one, we can definitely say she's in quadrant 2, right? But then we can do better than that. It certainly seems like they have the same x coordinate, right? And they have opposite y coordinates. Okay, and so again, we're just kind of getting a feel for how to deal with locations on the unit circle. All right, so same setup here. We've got a different person, Erin, right? She has run d miles and is in the second quadrant. It says her y coordinate is 0.4. Find her x coordinate. Okay, so again, I can make my sloppy unit circle here. Okay, so Erin's run d miles in the second quadrant, right? Now remember, this is the unit circle, so we know that this is a y value of 1 up at the top. So when we talk about y being 0.4, we can get a pretty good idea of where that location is. So 0.4, you know, is about right there. So that means if she's in the second quadrant and her y value is 0.4, that means she's right here, right? So this distance here, that distance has to be d miles. Okay. Now her y coordinate is 0.4. Find her x coordinate. Well, here's the nice thing. Remember that on the unit circle, if you have an x and a y, right, we now have language to talk about these. On the unit circle, x is going to be the cosine, right? The cosine of your angle. And in this case, we're using d, right? So this is the cosine of d, or the cosine of theta, right? Y is the sine of theta, right? That's what the cosine and sine do, is they give you your x and y values on the unit circle. So the way to approach this would be to say, let's use our Pythagorean identity that we learned, right? Her y coordinate is 0.4, so that means that is sine of theta, and we're going to square that. And just to be clear, I can't remember if I stated this in the previous video, something I usually always talk about in class is this weird business of saying cosine squared of theta. That's just the traditional notation, but it literally just means take your cosine of theta and then whatever that number is, square it, right? Those mean the same thing. This is just kind of the weird notation for it. All right, so cosine squared of theta plus 0.4 times 0.4 is 0.16. We can do that. So the cosine squared of theta is equal to 0.84. All right, now we need the cosine, not the cosine squared. So that means we want to take the square root of both sides. Okay, but remember, whenever you do a square root, you should be saying plus or minus the square root of 0.84. Now, which one do we want? Well, clearly, according to our picture here, if we're in quadrant 2, then we want to choose negative as our x value. Sorry, I'm having trouble getting my other colors here. There we go. So I want to choose negative for sure, and that's based on, right, based on being in quadrant 2. So we can say that her cosine or her x value is the square root of that. I'm just going to go ahead and give an approximation for that. So that means the cosine of theta is approximately negative 0.917. Okay, and that seems reasonable. It seems we know that x equals -1 is over there, so that, this seems like an x value that's pretty close to -1. All right, now it says Jason is directly across the track from Aaron. In terms of D, how far has Jason run? Okay, so let me grab a different color here. So Jason directly across. So if I drew a line right through here, this is where I'm going to find Jason. Okay, well, if he's directly across, then the idea is, okay, she went D. Okay, so how much further did Jason go? Well, you can see Jason went exactly half the circle more. So when we say in terms of D, how far has he run? He's run D miles plus another pi miles that Aaron hasn't run. Okay, and then lastly, it says if Aaron had started at 0, 1 and run D miles clockwise, where would she be? Okay, so that means, so her starting point's here, right? Now she's going to run clockwise, but she's going to run the same distance she did, so this same D. So what I want to do is definitely cover the quarter circle she covered, but I'm going clockwise. And then I want to cover this much here in this direction. So that puts her right about there. So what's her location? All right, well, this goes back to that last problem we were just working on, which said that if you start at pi over 2 instead, then the x and y values essentially are going to switch. So what would her x coordinate be? Right? It would be the y coordinate, right, from what she did originally, so from part C. So the answer would be that her x would equal 0.4, which agrees with what we've got here. It looks like that's about 0.4, that x value. All right, now in your notes, you have this page that says, I want you to complete section problem 21 from 5.3 of the text. We're going to completely ignore that, just because it's a cool problem, but it's not necessary to make sure that we have this stuff down. What I want to do instead on this page, though, is give you a nice trick, and it's a trick that I usually go over in class, so that's why I'm covering it here. A trick that I call the left-hand trick. And what this trick is for is actually going back to what you saw in the video notes about making sure that you memorize the sine and cosine values for important angles on the unit circle. All right, and one of the discussions that we had was that in order to make sure you know all the special values on the unit circle, it's actually just important to make sure you memorize the first quarter of the circle, because all the other special angles will go off of that, And what you can always do is just understand that the values that you get in the first quarter will be the same as the values you get for special angles elsewhere. It's just that you might have to, put negative signs on certain things. So what I'm going to do here is I'm going to make my rough sketch of the first quarter of the unit circle, right? And so remember, there are 5 angles that we want to have memorized here, right? So there's, of course, 0. Nothing much to that. There's pi over 2, or 90 degrees. There's exactly halfway, right? There's pi over 4, or 45 degrees. Pi over 3, 60 degrees. Pi over 6, 30 degrees. Okay, so we want to make sure we have these 5 memorized, and what we want to know are their terminal points. Okay, so we're going to go through each of them. And my suggestion in the previous video was, well, make sure they're memorized, and that's still the case. But what I want to do is give you a way to maybe memorize them faster, and if you really get stuck and maybe forget one, a way to figure it out again. Okay, so what I have to do to show you this trick is I've got to draw a hand on here, and this is just, I'm just going to apologize ahead of time about the drawing. It's not going to be very good. So that's supposed to be a thumb. That's supposed to be a pointer, middle finger, a ring finger, and a pinky. All right, so this is supposed to be my left hand, so this is the palm of my left hand facing us, okay? So if you are struggling to remember the terminal points, right? And with the terminal points, remember that they are, the x is the cosine, right? And the y is the sine on the unit circle, right? So if you're struggling to remember the terminal points, cosine, sine, here's the trick. It's always going to have the form the square root of something over 2. Oops, didn't mean to write that other 2 up there. Trying to find my eraser. Forgive me here. There we go. All right, so the square root of something over 2, that's going to be the form for both of these things. All right, now the thing you're going to put in the square root is where the left hand comes in. All right, so what we're going to say is you are going to bend the finger of the angle you are at. Okay. The number that you stick into the first square root for the x is the number of fingers above the bent finger. And the one you're going to put in for the y is the number of fingers below the bent finger. Okay, so let's try this. Obviously, I'm going to have trouble bending this picture, but you get the idea. So let's, I'm going to color in to say that that's bent. Okay, so if that one's bent, then in the first slot, square root of blank over 2, square root of blank over 2. There are 4 fingers, 1, 2, 3, 4, above and 0 below my bent finger. And of course, what does that do? Square root of 4 is 2, which just becomes 1, 0, right? And we know that this is the point 1, 0. All right. So now let's get rid of that. All right, so let's try it for another one here. So I'm going to bend the ring finger. So if I bend the ring finger, that would be at pi over 6. So this would be, right, square root of blank over 2, square root of blank over 2. So there are 3 fingers above and 1 below. But of course, the square root of 1 is just 1. So there's the square root of 3 over 2 as the x and 1/2 as the y that we know we're supposed to get. All right, then the next one, I bend the middle finger, square root of blank over 2, square root of blank over 2, but there are 2 fingers above and 2 fingers below. And so that's already what we want, square root of 2 over 2, square root of 2 over 2. Right, and then just remember that anytime you see this 1 over root 2, 1 over root 2, that's also the same thing. You just get this again by multiplying the top and bottom of each fraction by the square root of 2. All right, so moving on to pi over 3. Kind of get the hang of it now. Square root of blank over 2, square root of blank over 2. I'm bending this finger. There is 1 above and 3 below. So that's when we get 1/2 root 3 over 2. And then finally, right, if I'm bending this one instead, then I've got 0 above and all 4 of these below. So 0 over root 2, sorry, hold on. Square root of 0 over 2, square root of 4 over 2, which is going to be 0, 1. So that's the left-hand trick. And so if you're struggling at all to get these memorized, you can always use this as a nice handy trick to remember those special facts. All right, last example here. This one I definitely want you to pause and try to do completely yourself. It's just like the example that we did at the beginning. I'm giving you, to start off, one that's actually in quadrant 2 instead of quadrant 1, but try to come up with all these others. So definitely pause and do that, and then I'll show the solutions when you come back. All right, so let's try to approximate about where this is. You know, negative 5/13, 12/13. So 12/13 is, you know, way up here. That's probably about where t should end up being. So negative 5/13, 12/13. All right, so pi minus t. So if this is t here, right, a full quarter of the circle plus a little extra, then let's take a look at pi minus t. Switch my pen color up here. So pi minus t, I'm going to go pi, and then I'm going to backtrack t, which again would be a full quarter of the circle plus a little extra. And when I do that, it certainly seems like their y values are the same and their x values are opposites. So that would mean I'd be at 5/13, 12/13. Right? If I go negative t, then that means I'm going the same amount as my original, but in the clockwise direction, so a quarter of the circle plus a little bit more. So it certainly seems like there we've got the same x's, opposite y's. Pi plus t, let me change colors for this one. So pi plus t, so I'm going to go pi, and then plus t from pi. So there, it certainly seems like we have the opposite of x and the opposite of y. 2 pi plus t, I'm around once, plus t more, that lands me right back again at where t was to begin with. And then finally, when we're starting at pi over 2 and going from there, so pi over 2 plus t, so I'm going to go pi over 2. I'm going to add t, which is a full quarter of a circle, plus just a little bit more. Okay, with that, the x is now really long and the y is short, whereas before the x was short and the y was long. So we're going to get a switch of the two. So this is going to be, and it's clearly negative, right? Negative 12/13 and negative 5/13. Okay, but the values switched from what we started with. And if I do pi over 2 minus t, so I go pi over 2 and then subtract t, a full quarter of a circle, plus a little bit extra. Then again, we have that switching action, and it looks like I have a positive 12/13 and a negative 5/13.